thing that we are thinking about as we look at those two is this. We want, as you are looking at this, we are trying to think of, instead of it being the cube root, you might want to think of it as to the 1/3 power, as if we are looking at this, this means to the 3rd power, or the 3rd root of 8. That's what that 1/3 means. So, what number times itself 3 times gives us 8? Our answer was 2. In 15, when you're looking at 15, it had to the 3rd power, the 3rd root, if we are looking at it, if you want to think of it this way, of 1,000. So that's all that that's meaning, which then gives us the answer of what number times itself 3 times gives us 1,000 is 10. Right? So I think when you look at those fractional exponents, and we get into it a lot more, I want to put that away and take your notes and work it out. When we get into it in our next unit, we use these a ton more in the next unit. And you have to convert between the radical form and the rational form. So we'll be using this a lot more in the next unit. Yes? What's that? Yep, we can look at that challenge. So if we were looking at it, they all have the same base, right? So since they have the same base, we are going to be looking at 2. And the first one was to the, is it to the n? So we're going to have n plus 2 plus 1. You're adding your like terms on, which means we have 2 n's plus 3. You're just adding the like terms. And this is kind of going to lead us today. So the answers were in the back for you if you were checking those.
Don't you have to multiply 2 by 2 by 2? Yeah, that's in challenge 2.
But they have the same base. So you know you don't change the base to an 8. Just like if you were taking 8 to the 4th times 8 to the 3rd, you don't make it 16. It is still 8 to the 7th power. The base stays the same. Add the exponents. And I'll tell you that's an easy question that people will get wrong, because when they have something like 8 to the 1st times 8 to the 3rd, they want to do something like 16 to the 4th. It is wrong. It is not 16 to the 4th. That is 8 to the 4th. So, nope, it should stay, the base stays the same as we are doing. All right, so if you would please turn raised to another exponent. And I'm going to explain this mnemonic name in just a minute, because it kind of can help you to decide what you're doing with your exponents. So in this case, if we are going to write this out and we wanted to write out what it means, it actually means I should have how many 4 to the 5ths? 2 of them. And we know from today that 4 to the 5th times 4 to the 5th in our assignment, we are simply adding those exponents, which gives us 5 plus 5, which will give us 4 to the 10. And the question is there a shortcut so that I do not have to always write it out first as multiplication? So, the shortcut, if you're thinking, is to do what? We're going to multiply those exponents, and that is exactly what the shortcut is. Multiply the 2 exponents. That's exactly what our shortcut is. Now, I want to go back to this mnemonic that I gave you. And when you have an exponent raised to an exponent, what do you do with the 2 exponents? You multiply. So if you're thinking about this mnemonic, anytime I have an exponent raised to another exponent, you should multiply the 2. If I am multiplying, like today, what did you do to the exponents? You add them. If you are adding 2 terms, and they're like terms, like x plus x, what do you do to the exponent? Nothing. X plus x equals 2x. The exponent doesn't change, right? So, if you are kind of thinking about this as a mnemonic, when you have an exponent to an exponent, and let's say you have x to the 4th raised to the 2nd, you are going to multiply these two exponents. So that gives us x to the 8th. If you are taking x to the 3rd times x to the 4th, what are you doing when you multiply the base? What are you doing with your exponents? You're adding, getting x to the 7th. When you are adding, as we showed over here, x plus x, what do you do to the exponent? Nothing. It's simply 2x. So the exponent does not change. So sometimes this helps students to remember, oh, if I can write down name and I can kind of think of that going up, it helps me to remember what I'm doing, okay? Some people don't need that, don't like that. They just can understand the rules and get it. But I think that's a nice way of making sure you kind of understand what you're doing with exponents, okay? You'll see a bunch of them if you're looking for like exponent help, like ways to review it, help you remember things. So if we're looking at this next one, we're going to be multiplying. We should have 4 to the 6. Going to cross over here. Am I going to have 2 to the 2nd? No, just 2. And w to the 10. Here we're going to multiply the fractions. Comes out to be m to the 5/3. Next one, if we are multiplying, f to the 3 times 1/3 gives us f to the, if you wanted to put 3/3, but that is just simply going to be f to the 1st. You could leave it as f to the 1st, I'll always take that, or I would just take f if you are looking at that. So again, you can't keep them real simple. Got to get a little more complicated. Still not bad, right? So if we are multiplying, we want to do our rules, and some of these you're going to see that sometimes you might want to do negative exponents first, but as we start this one out, we're going to have y to the 3rd, and when we multiply these two, we end up with y to the negative 5/2 times -2 gives us just y to the negative 5. Do you agree? Okay, we are taking, if we're thinking about this, this was multiplying 5/2 times -2. And when you multiply, the 2/2 cancels and it stays negative. So my answer now, now that I'm multiplying the same base, because I got rid of that parenthesis, I now have y to the -2. Anytime it says simplify, that simply means we can have no negative exponents anywhere. So my final answer would be 1/y to the 2nd.
You added that.
The y to the 3rd is out here. So this was times, and 3 plus -5 gives me -2. So the next one, I'm going to start with my x to the 2nd. That nothing happens with that. Times, Soren, I'm going to have x to what power? -24. Next step, Josie, we're going to do what with our exponents? So I get x to the -22nd. Lainey, final answer, because this is in simplest form. 22nd. 1/x to the 22nd. Maria, we're going to start that next one. We're going to keep the w to the -2, but when we multiply outside this parenthesis, we end up with w to what power? W to the 5. So 5/3 times, those 3's are going to cancel in our denominator. Sanjay, next step, what are we doing with our exponents? So we multiply the base, add the exponents, gives me w to the 3rd. Done, right? Starting in that next one, Cassandra, we're going to start with this j. It's a power raised to a power, so we've got to get rid of our parentheses first. So it's kind of like order of operations. You always have to get rid of your parentheses and keep working to get smaller. So what are we going to end up with, Cassandra, when we multiply here? So I'm going to take -5 times a -1/2. So I'm going to leave it as 5/2. 2, right? Positive 5/2. Next, this had nothing outside the parentheses, so it's like a 1. It's just showing multiplication. J to the 3/2. Gavin, what are we doing with our exponents?
You add them.
Which gives me? Simplifies to what? J to the 4th for us. Final answer. So anytime you can simplify, they almost always leave those fractional exponents as improper fractions, but if you can simplify, you want to do so. Okay? So tap that next page is when we start looking at taking more than one thing to a power. To this point, everything was just, there was one thing to a power, we just multiplied, and we kind of just continue with that same rule. So it says when we are looking at this one, on that next page down, it says you can use repeated multiplication, like 4 to the negative 1/2, to the 3rd power. And we can write each of those out 3 times, but again, we kind of want to use our rule. It says we can take 4 to the 3rd power, and m, and take 3 times 1/2 and get m to the 3/2. When you finish simplifying that, the 4 to the 3rd, you definitely want to put that in your calculator unless they tell you to leave it as a power, and you get 64 and m to the 3/2. And you're going to leave it that way. So when you are looking at these, it just says if there's 2 things inside that parenthesis, or 3 things, or however many, you have to take each thing to that final exponent. So you have to take 3 to the 4th and the x to the 4th, and then simplify it. Okay? So top the next page. The first one start, again, kind of simpler. So if we are starting, we are going to take, Whitney, 7 to what power? 7 to the 3rd, and Owen, I'm then going to have m. Okay, so if I take m to the 9th to the 3rd, exponent, if I'm thinking of that, what am I doing with my, when I have an exponent to an exponent, I am going to do what with these 2? It'd be 27. We're going to multiply them, right? So if I'm finishing the problem, Kylie, did you put it in your calculator yet? 7 to the 3rd?
343 and
Yes. Good. Questions? So there are 2 ways to do this next problem. I want you to show me that you understand your negative exponents. So this is over 1. My first step is to make it positive. To make it positive, I'm going to rewrite this as 1 over 2g. And now it's not going to be negative 4, because if you think of that steps in that first video, it is now to the 4th power. I will be asking you to keep these as fractions, not decimals. So we are now going to take, at this point, Elena, I'm going to have 2 to 1 over 2 to what power?
2 to the
4th. And then Jack, I'm going to have g to the 4th. So Evie, if I'm putting my answer, I'm going to have 1 over 16, and then g to the 4th. Okay. So sometimes it makes sense to take 2 to the negative 4. So I had someone say, I'll always have a couple of students go, I didn't do mine that way, Mrs. Thompson. I did 2 to the negative 4 and g to the negative 4. Okay, you can. And you have that over 1, but then you're going to do this step next anyway. So it doesn't matter what your first step is, you still should end up getting that, and we are not going to have decimals for these. You are going to keep them as fractions. Okay? Do you not have your word? So if you want to write this one down then. So let's write down the problem. 3c to the 5/2 raised to the 4th times c to the 2nd raised to the 3rd. So first thing we have to do is take each thing to a power. So Dylan, start us off. We're going to have 3 to what power?
3 to the 4th power.
3 to the 4th. Next, Mallory, I'm going to have c to the... Can you tell me what we're doing with our exponents? Because we're going to multiply, right? So we have 20 divided by 2. 5 times 4, 20 divided by 2, c to the 10. Thank you. If we keep going, Emmy, c to the to the 6th. So we are now simplifying. So if we are doing that, Caleb, I'm going to have 3 to the 4th. Do you have that one, or do you have your calculator? And if you're thinking of it, 3 to the 2nd times 3 to the 2nd. So 9 times 9 is 64. Okay. 3 to the 2nd. Or 81. 81. Yes. So I'm going to have 81. And then I'm going to have Abby C to the 16. Okay. All right. So if we are continuing with that next one, as you are taking a look at that, tell me as you start the next one, what are you thinking of, Caden? 6 to the 3rd. Caden in front of him.
8 to the 3rd and B to the 3rd.
8 to the 3rd, B to the 3rd. Jacob, 5 what? 5 to the negative 3. And 8 to the negative 6. Why did 5 go negative 3? So when you look at it, if you think about this, this is 6 to the 1, and 1 times 3 is, so this one is 5 to the 1st, and 5 times 2 gives us 5 to the 2nd, when we are looking at this. So definitely would probably use your calculator for this one with 6 to the 3rd and 5 to the 2nd if we were regrouping them. So you can put that whole thing in your calculator and get 5,400. Then I'm going to group my a terms together. So I have a to the 3rd and a to the negative 6. I have
450. 6 to the 3rd is 100.
6 to the 3rd is 216
216 times 25.
times 25. You can even put the whole thing in your calculator like this, or you can put in that it is 216 times 25. These are all being multiplied. So yesterday on one of the homework quizzes that I'm going to be handing back shortly, I had people all of a sudden put in an addition sign into the problem. There's no addition. Are you adding these exponents? Definitely adding the exponents. But this does not become addition. So we're looking at 5,400, and it should be a to the negative 3 at this point and b to the 3. But we are not done with the problem. What do we have to do to finish it?
I have to get rid of the
Okay, so tell me, how can I get rid of the negative?
400 B to the 3rd, and then 3rd is 8 to the 3rd.
Okay, as we are looking at that. So, tonight, you are going to be working on 11 to 33R. After you do 1 or 2 questions, check the answers in the back. It does you no good to do them all wrong. And then my hint is that if you finish this, so you are looking at the 43 to 61. They're just asking you to fill in that blank. And then they get a little more complicated down here when you are looking at the 43 to 61. You're doing the odds for those. Be careful when you have addition, right? That's going to be different than what we've been doing with multiplication. And then I think tomorrow is when we will have your quiz that we are looking at. So as you start doing this,